Welcome back. In this module, I want to compare what you've previously learned how to graph with what we're about to learn how to graph. So if you look at your PowerPoint, it's broken up into two parts: linear equations versus quadratic equations. Remember, linear equations are what you learned to solve in Algebra 1, and quadratic equations is what we just learned how to solve in 099 Algebra 2. So let's take a walk down memory lane and look at linear equations. So think back to 098 Algebra 1. An equation that's linear is degree 1, which means the variable has an exponent of 1. Because we're graphing, not only do we have the variable x in our equation, now we have the variable y. So if you look, an equation in the form ax plus by equals c, where x and y have invisible exponents of 1, we know that's a linear equation. When we went to draw a picture of that, it became a line. And that's where the word linear comes from. It's Latin for the word line. Back in Algebra 1, when you graphed a line, there were three ways to draw a line. You could draw it straight across horizontally, up and down vertically, or slanted diagonally. Now, there was some vocabulary words you talked about with lines. If you look, we talked about the words x-intercepts and y-intercepts. An x-intercept is where your line touches the x-axis. It's an actual point where the line will cross the x-axis. The y-intercept is where the line crosses the y-axis. So if you look at your three lines, the first one's a picture of a horizontal line. Well, it has a y-intercept at y equals -1, because that's where it touches the y-axis. On the vertical line, the second picture, it has an x-intercept at x equals 3, because that's where it touches, the line touches the x-axis. And then if you look at the diagonal line, it has both an x-intercept and a y-intercept because it touches the axes both places. Another word you had mentioned when we graphed lines back in Algebra 1 is the concept of slope. Slope is the slant or the steepness of the line. It's the movement from point to point. And if you remember, when you plot point A and you get to point B, you move the same way as you go from B to C and C to D. So that's what you previously have mastered. Now look at what we want to learn how to do. We want to learn in Module 19 how to graph a quadratic equation. Well, first thing, a quadratic equation doesn't look like a linear equation. We know if an equation is quadratic, it's degree 2. So our equations for graphing will look like y equals ax squared plus bx plus c. You see the x squared? It's quadratic. When you graph a quadratic equation, it is not going to form a line. It's going to form a graph called a parabola. And what a parabola is, it's a curve. And if you look at the PowerPoint, I have 3 examples of those parabolas. 2 turn up, face the sky. 1 turns down, facing the ground. And that's what a parabola looks like. It looks like the letter U. So anytime we're graphing a quadratic equation, we know the picture is not going to be a line. It's going to be a curve called a parabola. Now, we can use some of the same vocabulary with parabolas as we did with lines. Parabolas can touch the y-axis. If you look at all 3 diagrams, all 3 of those parabolas touch the y-axis. Therefore, all 3 have points that are called y-intercepts. Parabolas may or may not touch the x-axis. If you look at the first parabola, it touches the x-axis at x is 0. If you look at the second parabola, it touches the x-axis at -3 and +1. And if you look at the third parabola, it doesn't touch the x-axis at all. So some parabolas have 2 x-intercepts, some have 1 x-intercept, and some have no real x-intercepts. And another word you're going to hear for x-intercept is the word root. So don't get confused with that. Lastly, there are 2 vocabulary words that relate to parabolas only that have nothing to do with lines. The 2 words are vertex point and axis symmetry. If you look at your parabola, there is always on a parabola 1 point that's all by itself, and it's highlighted in blue. It's the point that's either the highest, the maximum, or the lowest, the minimum, and that's called the vertex point. So every parabola has that 1 point that stands by itself. Every parabola will have an axis of symmetry. Now what that is axis means line and symmetry means the same. So that means through every parabola you could draw a line that will cut it so it looks the same. And in your diagram it's drawn in green ink. That line that's drawn straight down the middle, that's going right through the vertex point, is called the axis symmetry. And it will show the left side of the parabola looks identical to the right side of the parabola. And that's what you want. Because when you go to plot a point on the left, it better have a buddy on the right to match up, to be symmetrical. What you do not hear with parabolas is the word slope. And that's what I want to make us think of. Slope is specifically a vocabulary word related to graphing linear equations, lines. So you're not going to hear us talk about slope with quadratic equations, parabolas. Instead, you're going to hear vertex point, axis symmetry. The words that both equations have in common when you graph are x-intercepts and y-intercepts. So now that we understand our vocabulary and we understand what our graphs look like, now we're ready to begin graphing parabolas, quadratic equations. So I'll see you in the next module.